Hello everyone, we're going to keep doing these verify problems, but we're going to do some today that have some tougher things going on. So there's a little bit of factoring going on. We might have to use the conjugate. Sometimes you do a problem and you don't really need one of these, but these are often very helpful strategies. So let's talk about first one here. It says sine to the fourth minus cosine to the fourth. Anytime I see something higher than degree 2, I'm thinking, how can I factor this? And these are both perfect squares. So you can actually think of this as dots. If it was a to the fourth minus b to the fourth, that's a squared plus b squared, a squared minus b squared. So these are perfect squares. So I'm going to do the same thing with sine and cosine. We're going to say sine squared x plus cosine squared x, and then we'll also do sine squared x minus cosine squared x. So this is dots. And you might see kind of immediately that that's going to help us because in the denominator we have sine squared x minus cosine squared x. So this factor can cancel. And then you have that, and you're like, wait a minute. That's the thing. That's the thing, right? That's Pythagorean identity. Sine squared plus cosine squared, that's 1. We're trying to show that it equals 1. We did it. So we did it in one step. We just had to factor. So this looks really scary, but if you know difference of squares, you've done in one step. Cool. What about this guy? So this is a good example of when the conjugate is a helpful thing to try. You see that you have sine and cosine, so you can't convert it to sine and cosine. You don't have anything squared. If that was squared, maybe we'd have an identity, but it's not, so we don't. So you really don't have a lot you can try. And then when you don't have a lot you can try, you just sit and kind of stare at it like, what am I supposed to do with this? One thing that is something that's worth trying is look at, I usually focus on the denominators. If you have 1 plus sine of x, let's try and multiply by the conjugate and just see what happens. 1 minus the sine of x. This is a helpful thing that happens in a lot of different problems that you do. In these trig proofs, oftentimes it's a useful thing to do. So what I'm going to do is in the top, I'm going to leave it alone. I have cosine of x, and I'll just say times 1 minus the sine of x. And if you kind of look as you're working, you're like, wait a minute. There's 1 minus sine of x. That's good. That's probably a good thing. Over. Now, in the denominator, you have 1 plus sine x, 1 minus sine x. And this is the whole thing about the conjugate. What happens when you expand that is you get 1, and then you have minus sine x, and you have plus sine x. Those are going to cancel out. But then you have plus times minus is minus sine squared x. So these cancel out, which is kind of the idea. When you do this, what you end up doing is creating this now at a higher level into quadratics. 1 and sine squared are both perfect squares, so you're creating this idea of dots, but really you also are creating an identity. That's a thing. 1 minus sine squared is cosine squared. So I can write this as cosine of x, 1 minus sine of x. But now, instead of, in the bottom here I have 1 minus sine squared, I should remember that's an identity. 1 minus sine squared is cosine squared. And now you can say, hey, cosine, one of you can cancel out, and you have 1 minus sine of x over cosine of x. And that's what we were trying to prove. So we're done. We did it. The trick to that one, though, was multiplying by the conjugate. If you don't know to multiply the conjugate, you're probably not going to ever get that problem right. So this is just one where it's a strategy you need to you understand, can be helpful, multiply by the conjugate. So take whatever that sign is, flip it, the same two terms, one with plus, one with minus, and you end up with this identity, which is nice. Let's see, another conjugate problem. 1 over cosine, sine. I don't know if we need to. Let's try and do this in terms of sine and cosine first. So secant is 1 over cosine, and I don't know if this is going to work, but I have a pretty good feeling about it. No, that's not going to work. So I'm going to end up with 1 plus the sine of x over cosine of x, and then I kind of am ending up, I'm in the same situation where I'm going to go in a circle. I don't have anything I can do. So by converting the sine and cosine, I look at it and I'm like, there's just not a lot I can do here. I'm kind of stuck here, and then I'm going to end up with the conjugate anyway. So I'm going to come up to this side, and I'm going to try the conjugate again. So instead of 1 minus sine x, we'll do 1 plus the sine of x. See if this works. Because that otherwise seemed kind of be a dead end. So cosine x, 1 plus sine x. And now in the denominator, this is the same thing we just did. This is 1 minus sine squared. This is 1 minus sine squared x when you expand it, which is cosine squared x. So this cancels out, and you have 1 plus the sine of x over the cosine of x. So if you look in last problem, we have 1 plus sine of x. Now it's pretty much the same thing, but we have a different sign. Now we get to this, and you're like, that's not secant plus tangent. It's not, but it's kind of there. If you look, 1 over cosine is secant, sine over cosine is tangent. You just need to know that you can split it up. 1 over cosine of x plus sine of x over cosine of x. So make sure you understand why I'm allowed to do this. They have the same denominator. I'm just separating the numerator, 1 plus sine of x. If I were to put this back together, I would add them over the same denominator. But now, the reason I separate it is because now I can see that 1 over cosine is secant and sine over cosine is tangent. So we did it, because that's what we were trying to prove, was secant plus tangent. So again, conjugate helped you again. Those two, nice. Let's see. Is this a conjugate problem? If I see stuff on the right side that like maybe I can convert to sine and cosine, maybe I'll try that. And this might be one I can do multiple ways. I'm sure I can do it multiple ways. But let's see what happens if I write this out. 1 over cosine x minus sine of x over cosine of x. Okay, that's 1 minus sine of x over cosine of x. And that's going to get squared. So this is one where it's like, all right, what am I going to do now? I'm tempted to maybe expand the top. Oh, my lights just flipped off. I'm going to fix that because it's messing with me. So I think I want to leave the top alone. I'm just going to write this as 1 minus sine squared x in the top. And in the bottom, I'll write that as cosine squared x. Now, the reason I'm doing that is because I'm kind of thinking like, this looks an awful lot like an identity. This cosine squared x. If you remember, like this is 1 minus sine squared x, right? Like cosine squared x. If you do cosine squared x plus sine squared x, you get 1. So if I see cosine squared x, that's cosine squared x would be 1 minus sine squared x. So what I'm going to do is, now I'm going to do a substitution, but I'm kind of going the other way. I'm taking this, and I'm going to write it as 1 minus sine squared x. So in the top, I wrote this wrong. This is 1 minus sine x squared. It's the quantity. So that's not actually the same thing. That's 1 minus sine x, 1 minus sine x. That's what I have in the top. But in the bottom, now what I'm going to do is my substitution, cosine squared x, I'm going to write as 1 minus sine squared x. And then what that's going to let me do is factor. So I'm doing a substitution, but I'm also going to factor this is dots. So in the top, I have 1 minus sine x times 1 minus sine x. But in the bottom, I have dots. This is what we factored earlier. 1 plus the sine of x, 1 minus the sine of x. So now, I can cancel out one of them. Am I done? Hey, I did it. Oh, cool. Okay, that's it. That's the end. All right, so let me go through that again, because that was kind of a big jump. First thing I did was I got common denominators. They're both over cosine, so that was easy. And that was 1 minus sine over cosine. Now, that whole thing's being squared. So the numerator is just going to be something squared. It's just that squared. But the denominator, cosine times cosine, is cosine squared. Now, knowing that this is a thing is important because I'm going to go backwards. And also knowing that 1 minus sine squared is a perfect square. There's a perfect square that's dots is also important. That's kind of just like, hey, I think I can factor. I can get rid of one of these, 1 minus sine x's, if I use that idea of dots. So I took this guy and I factored it using dots. And I was able to cancel one of my 1 minus sine x's. It was kind of tricky. A couple more. This one I think is really easy. This is one where if you catch the property, you can do this really quickly. That's a thing. Sine of x times, that's cosine squared x over cosine x, which I'm going to write maybe kind of off to the side. Because if you notice, this one's, you're like one and done. That is tangent of x. Tangent of x times cosine squared x. So there's probably other ways you can do that, but that's definitely the way you want to go on that one. So all I did was do one substitution, and I was done. Whoa. Okay. One more. All right, so I got this denominator. I think I'm going to try this. If I can mess with sine and cosine, I like to try that. It's not always the best play, but it usually gives you an idea. So I'm going to make this all in terms of sine and cosine. So cosecant is 1 over the sine of theta, and cotangent is cosine over the sine of theta. So I already have a common denominator. That's nice. So 1 over in the denominator. My denominator is sine of theta. But I have 1 plus cosine of theta, which I think this is going to be pretty straightforward. Although, maybe my sign is wrong. I don't think these is right. I think that's supposed to be a plus. Because when I copy, change, flip, I'm going to go copy, change, sine of theta over 1 plus cosine theta. Sine of theta over... Okay, so, man, that's not helping me. I'm like going in a big circle here. Trying to get a minus. So maybe what I should try and do instead, because I'm just kind of going in circles, is the conjugate. You could do it here, or maybe I'll just do it in this first one. Let's try this. 1 plus cosine theta. See if this helps us. 1 plus cosine theta. Top and the bottom. So in the top, I have 1 minus cosine squared, because that's dots. And in the bottom, I have sine of theta, 1 plus cosine theta. And then I'll make this cosine squared, or no, I'm sorry, sine squared theta over. Sometimes you get stuck. So now I can cross out a sine. I think this is going to do it. So I have sine of theta over 1 plus cosine theta, which is, hey, look, right here. All right, so this is kind of a different way of proving it. But what I did here is I messed with the left side and I messed with the right side, and they ended in the same place. So this is a totally viable proof. Like, we have shown that these are the same thing because I messed with the left side and I messed with the right side. And even though they don't look exactly like the other side, they look like each other. So I've proven that I can do it. I just haven't quite got to this 1 minus cosine. Maybe I needed to do the conjugate down here. So just because I want to see if I can get there, I'm going to keep going with this. I think I'm going to get there like this. So now I have sine of theta times 1 minus cosine of theta over. Now I have 1 minus cosine squared in the bottom because I'm going to expand that. And now I end up with, there's my bell. Over 1 minus cosine squared is sine squared theta. That goes, no, one of them goes away. Maybe. Now I have 1 minus cosine theta. Oh my gosh.
Would you please stand for the pledge?
Let me pause it. Okay, no more announcements. So 1 over cosine theta. Let's see if I can, I'm almost there, I think. This is going to be over, I have 1 sine of theta in the bottom. So now I have 1 over sine is cosecant theta, and cosine over sine is cotangent theta. So is that this? 1 over cosecant plus cotangent. Oh my gosh. Just not getting there. Which is okay because I've kind of already shown it, but it's a little irritating. I'm going in circles and I'm not like progressing. So I'm going to kind of work this one out again and then see if I can come back with a better solution. But here you go. That is a totally viable, mathematically legitimate proof. If you have to mess with both sides and end them in the same place, you can, but that's not always like the most convincing. So I'm going to play with this and come back and see if I can get you the better version. So sit tight. I'll be right back. All right. I got a good proof here. I think this is going to look better. And I really should just follow my own directions. And when it says use the conjugate, we should use the conjugate. So I'm going to come over here and I'm going to use the conjugate for this. CSC theta minus cotangent theta. And then I'll do that on the top and the bottom. It's going to make this a lot easier because in the denominator, I have dots, whoa. Cosecant squared theta minus cotangent squared theta. So this is dots. You expand. Cosecant squared plus cotangent cosecant minus cotangent cosecant. Those cancel. Minus cotangent squared. And in the top, I have cosecant theta minus cotangent theta. Now the trick to this one, thing that makes it easy is right here. That is a thing. That's a Pythagorean identity. If you have cosecant squared minus cotangent squared, that's 1. So this is 1 because of an identity that we know. So really now what I have is cosecant theta minus cotangent theta, which now I can do my sine cosine trick, 1 over sine of theta minus cosine over sine of theta. And you can see they have a common denominator, which is sine of theta, and in the top, 1 minus cosine theta, which is What we're trying to get, woohoo, just use a conjugate. So, what I was saying before, what I did earlier, where I worked on both sides, is a viable strategy, but I just don't think it's ever as convincing as taking one side. So that's why I wanted to rework this and show you how sometimes you get stuck, but this is sort of like, okay, I know for sure that I crushed this problem because I've proven it essentially 2 different ways now. So that's awesome. So make sure you do your practice problems. If you can do that, it's pretty good, pretty good. Like and subscribe. Good luck.